I'll maybe just start with a little bit of my background. So I have an interesting career because I grew up in Los Angeles and I worked in television as a child, not as an actor, but
Recording in progress.
but I did it on my dad had a production company, and I learned all of the equipment from video editing to cameras to lighting, and then that stuff really kept or stuck with me for a lot of my career, and I was able to actually merge the television work that I did with some of the work that I was learning when I was working at Caltech in IT. And what happened was after I worked at Caltech for I think 3 years. I was still in the Los Angeles area, and there was a lot of exciting things happening with film. And in particular, they're building pipelines, and film pipelines are actually very similar to what we're building today with machine learning pipelines and data engineering pipelines. So 20 years ago, believe it or not, people were doing very similar things to what we're doing now with data engineering. And in fact, there was a centralized file system. There's high performance compute clusters. You're doing computer vision. It's almost shocking how much stuff that was happening in film is now being recreated in the machine learning industry. So that was really a great foundation for me. As I got more and more experience, I worked at Disney Feature Animation on their first 3D animated film. I also was running the screening system when Michael Eisner was still there, and did like live screenings, and that was kind of fun. So I learned actually a decent amount about video and audio in terms of film. And then later I worked at Sony ImageWorks, and at Sony ImageWorks I worked on a bunch of fun shows like Spider-Man and Chronicles of Narnia and all these kind of cool shows. And what was cool about that experience was it really gave me a good understanding of what it's like to work with a group of engineers who are multidisciplinary. Sony, in my opinion, is probably the best engineering company I've ever worked at because of the culture of their company. Where Sony, I think on the first day, they give us the history of the company, and it was post World War II. In Japan, they created a rice cooker, and that rice cooker then later they turned it into making technology for Walkman, and then they just kept innovating. So, my opinion, really a very fascinating company, and I learned a lot today that I still use from my time at Sony. Later, I moved to the East Coast and worked in Turner Studios for a bit, worked at also some startups, and then I moved to New Zealand, lived in New Zealand for a while, and I worked on the Avatar movie for Weta Digital, and also had a lot of experience with high performance computing and scripting and moving things around. So really, I think there's a great variety of experiences that I had with film that really helped me in the second part of my career. After I finished up on the movie Avatar, I moved to the Bay Area, lived in San Francisco for roughly 10 years or so. And one of the things that I did was learn about, being a CTO, being a general manager, and also building machine learning systems from scratch. And that's one of the things that was the most scary, is building, production-based machine learning systems. And where that really culminated was when I was working at Sports Social Network, and we had really large traffic. We had millions of monthly users, and we're working with some of the largest soccer clubs in the world, like Bayern Munich, and top soccer players. And one of the things that we're trying to do is figure out how to do growth hacking. And so that's really some of the stuff I cover in the book is what we did, how we used Mechanical Turk to label the data, and then how to use those signals to predict who are the people that we should partner with. And in fact, today we did this about 2013, but today this is now a big thing, right? We were doing influencer marketing and paying creators, or the creator economy, back before it was really like a huge deal. Now today people are doing this. They're paying creators, they're paying influencers, and so there's a lot of really good experience. Then later I moved into teaching at UC Davis. I've taught machine learning, I've taught cloud computing, and I've also taught as well at Northwestern. I teach machine learning and data engineering and data science there, and a little bit at Duke as well with data science and cloud computing. So in a nutshell, I've had a kind of a mixture of different jobs here, and different things that have culminated in me now mostly focusing on writing books, creating courses, and things like that. So that's my background. Let me start now with sharing my screen here, and I'm going to move into screen share here. And so here's really my, the idea that I wanted to start with was, MLOps 0 to 1. What is it? How do you get started with doing machine learning operations? So I already mentioned all this stuff. I'll also mention that I have written a lot of books, and I'm continuing to write books. I'm writing a book right now with O'Reilly called C# on AWS, and I do consulting with Fortune 100 companies and startups, and I'm the author of the book Practical MLOps. Happy to connect with you on LinkedIn as well. So here's the agenda. What we're going to talk about, why MLOps, what are the use cases of MLOps, how to do some deep diving. So we'll get into some of the things of building a machine learning system, and then do Q&A. Okay, so first one is why MLOps. So I guess to start with is why do we need MLOps, and what is it? How does the COVID-19 crisis reveal the need for MLOps? And then how to get started with MLOps, and what are the MLOps platforms? So let me just start with these questions here. And I think the first one is that we really do need to get better at putting machine learning into production. And in particular, one of the things I think that's important is that we're able to be more results oriented versus thinking about the technique. And I think that's really where we've had a crisis with data science, is that there's been a too much of a focus, I think, on Kaggle and the technique around Kaggle, and not enough of a focus on, can we get it into production? Can we push this out? These are the things I think that are important to do when you're dealing with MLOps. Is really, are you solving a problem? And so the COVID-19 crisis, I think, is also revealing the need for MLOps. And in particular, one of the ones is drug discovery, and also, analyzing patterns. I think all of these things are really important for society to get better at, and also analyzing what are ways that we can help humanity. Like, can we prevent diseases in the future? So I think we really can't be complacent with our technology. I think we need to be focusing on building AI and machine learning that helps humanity and solve some of these problems, like, for example, with the pandemic. And so now the next question is, how do I get started with MLOps? And then I'm going to go into that in a second. In a nutshell, I would say you really do need to start with the foundations, which is DevOps. And then finally, what are the major MLOps platforms? We'll talk about that as well. Okay, so where are things headed? The Wall Street Journal reported on October 6th that there were 775,000 jobs in cloud for 2020, and this is up from, let's say, 400,000 in 2019. And so really the things are headed towards cloud computing inside of what we're doing, and for data science. And really, in a nutshell, I would say the other things that are fascinating are that data science itself is being diminished. And so if we look at data science here, we've got a lot less job titles, because I think it's really ambiguous or unclear what a data scientist does. In some cases, it's clear. Like, for example, if you're a journalist and you're analyzing, I don't know, let's say science around the pandemic, or you're looking at health reports or something. Okay, that sounds a little more towards like a data scientist, because it's pure research that's getting turned into a product. But I would maybe call that a data journalist. But I think just vaguely data science, it's a little bit too ambiguous, in my opinion. I think it's more clear if you have a domain that you're focused on. For example, you're a healthcare worker and you're looking at maybe disease prevention, and you're using data science skills. I think that makes more sense. So what I think is going to happen isn't that data science itself isn't an important skill to learn. And in fact, I would say it is. I would say it's so important that you should be teaching data science in, let's say, 7th grade. It's that I don't know if it's necessarily a job title. And we see this, panning out in terms of the job market, right? We see cloud computing is just, a juggernaut. Really, cloud computing, there's tons of openings. There's data engineering. There's tons of openings with data engineering. Machine learning engineering, there's tons of openings with machine learning engineering. So that's really what I think is happening. Is it's the specific skills that are tangible. Like, for example, if you look at a construction worker, there's roles that construction workers do where you have a tractor. The tractor is, moving the dirt around. That person that's moving the tractor and grading the land, that's a very specific skill. They know how to drive a tractor. They know how to solve a very specific problem. I think it's similar with what's happening with cloud computing, data engineering, machine learning engineering, is that we're looking for people with very, very specific skills. So to get started, I think this is really a critical thing to consider for your organization. Is if your organization doesn't think about this hierarchy of needs, I believe you will have a big problem. And in particular, I think the first place to start with is DevOps. So, in terms of DevOps, are you automating your infrastructure? Are you checking code, into production that's tested and automatically deploying those changes into production? These are critical, right? These are critical problems to solve. Likewise, with automation of data, like, are you automating your data? Is this something that, is there a flow of data that is actually you're able to capture and do things with? If you don't have automation of your data, it's probably very difficult for your organization to do machine learning at scale, right? Because you have to go, basically manually collect this data and do operations with it. Likewise, I think another thing that we're seeing as a trend is platform automation. Why are you using your own platform? You should be using, for example, tools and platforms like SageMaker, for example, or Azure ML Studio or Vertex AI or some other third-party platform. And those third-party platforms allow you to work at a higher level. Plus, you have a common source of reference, right, or a frame of reference. And this common frame of reference allows you to build at scale. And then with MLOps, I think this is maybe the final piece here with MLOps, is that you're able to culminate the MLOps material into something that you put into production. So I think this is really the way to think about things, is that these are all forms of automation, and they're basically sequential, and you must start with the basics, which is DevOps. You can't do machine learning automation or MLOps without having DevOps first, next data, next the platform. Now, if we talk about continuous delivery of MLOps, we've got infrastructure as code, we've got cloud, we've got in-number environments. And in particular, this is one of the things I think you'll see, is that you have GitHub, and you have multiple branches, and those branches will push the code into different environments. So really, a branch inside of GitHub, the branches will correlate directly with a production-based environment. And in particular, one of the things that you'll see here is that this continuous delivery process is very important. If you don't have some kind of continuous delivery process for your software, you can't automate the machine learning, because the machine learning has to sit on top of the automation of your software into the cloud. So, in general, it's testing the code, infrastructure as code, deploying the code, and then finally, this is Kaizen, right? Which is this idea of automatically improving, your software. This is the core capability that an organization needs in order to do machine learning operations. So data operations, here's a diagram where I think this is a good way to think about it, is that you've got, a water hookup. And I think that's the best way to think about data operations is, if you want to have a dishwasher, if you want to have a shower in your house, you want to have a hot tub, you want to have all these things you can do with water, you need the water that's cleaned and delivered from the city. Also, once you've done something to the water, you need to put that water back out and go to the sanitation system to clean it. So similarly, with a infrastructure like this, where you have a data lake, you need to be able to hook the water in or hook the data in, and you need to be able to do things with it. So you need to have a jobs framework, right? So the jobs will run at a periodic interval. You need to have a feature store, and the feature store will be able to collect and hold out, different components of the data. And then you also need to have the ability to do serverless data engineering. right? These are all important things that we're seeing. They're emerging trends with cloud computing. And then finally, big data processing, right? Can you manage code inside of the big data system, and are you able to do it at scale? Like, can the compute and storage keep up with what you're building, or are you doing things at a small scale structure? And then finally, model versioning, right? Like, are you able to take your model and version this code and do things with it so that you can go back in time or figure out what the lineage is of it? Now, in terms of platform automations, I did talk about this a little bit, but the core idea here is that you've got this data science workflow, right? You've got ingestion. This is very common, right? If you're just doing a toy project, you have to get the data from somewhere, right? Even if it's downloading a CSV file. So stage one is ingestion. Stage two is exploratory data analysis. Stage three is modeling. Stage four is the conclusion. So this is really the data science workflow. This is what most people are comfortable with. But the problem here is that there is a lot of logistics underneath the hood of things spinning up and spinning down. And so in particular, here's a good example. We have SageMaker. The notebook instance will get spawned, but that's a machine itself that has to be run. Likewise, if you're going to train your model, you have a distributed principal component analysis job or a k-means clustering job, that those are going to require clusters of compute, and they'll also require something that can scale disk IO up and down. And that's why Amazon S3 is so important, because it serves as a data lake for the ability to scale up and down. And then you've got distributed hosting right here with a k-means endpoint or a principal component analysis endpoint, which again has the instances that are below here. So there really is a problem in terms of how do you orchestrate all this stuff, and that's why you need a platform. Now, it doesn't have to be SageMaker. It could be some other platform, a third-party platform, or a different cloud platform. But in particular, this is not really what you want to be building yourself when you're working with machine learning. Now, the feedback loop, I think, is another important thing to consider when you're building machine learning systems, right? You need the ability to create and retrain a model with a reusable ML pipeline. You need to have continuous delivery of MLOps. You need to audit the pipeline. You also want to look at that data drift. So if the last time you changed the model, then, or you train the model, there's a bunch of new data, you want to have this feedback loop hooked in. So really, there's a lot to be said here about thinking through the feedback loop for your system. And I think this is an emerging area of MLOps where some new frameworks are starting to handle this. One in particular that's kind of interesting is Aguazio, which runs MLRun, has this concept of retraining pipelines because they use Kubernetes-based system. And I think this is what we're going to see in 2022 is we're going to see a lot of retraining pipelines that allow people to, move data and move models more quickly and adjust to things. So if you put a model into production, that's great. And it's great if you can keep putting the model to production, but are you able to analyze what it's doing in real time and then adjust your model training to that? And that recursive feedback loop where you put the model into production automatically, measure what's happening, and then retrain it based on what's happening. That, I think, is really the holy grail of machine learning operations. And I think we're going to see more and more of that. The other concept I think that we're seeing quite a bit is create one, deploy many. And so this is a great example of, we have a machine learning platform. For example, let's take Vertex AI. And so in terms of Vertex AI, you're able to train a model and build it out into many different components. You have an edge-based device, you have a JavaScript-based device, you have a native mobile-based target, a container-based target, an API target. These I think are going to be the things we're also going to see a lot, and we do see it, right? With Vertex AI and AutoML, you can take your data, upload it to the Google AI platform, train a model, automatically get all of the metrics about how the model is doing, and then click the button, it'll deploy to these different targets. Again, Edge, JavaScript, native mobile, container, and API. So what's powerful about this is that you're able to do one thing but profit in many different ways. And this allows you as a developer to not have to focus so much time on like recreating all these different things. So I think we're going to see this as the result of technologies making it a lot easier to build out machine learning. Okay, here's another one that I think is an important one, which is something I call the rule of 25. So there is no silver bullet. And I think with machine learning, it's easy to say, oh, it's data centric, oh, it's model centric, which again, there's people that have a lot more experience with machine learning in particular than me. But I would disagree because I see the world as a software engineer and a CTO or engineering manager. And what I've found in my career is that you can't think about the silver bullet. In fact, you need to think about things holistically. And my opinion with MLOps, what's really the problem and why we're not getting models into production is that people are not thinking about holistically the system. So 25% of the problem is DevOps. Like, are you building things for DevOps? 25% of the problem is data. Are you building things for data? 25% is the models, right? Are you building these models and putting these into production? And then 25% is the business. Like, do you even have a problem that's defined enough that you actually are working on the right thing? And I think the business one in particular, we don't hear that many people talk about it. I mean, there's a little bit of talk about it, but you could do everything right? You could have a lot of automation with DevOps. You could have full automation with data. You could have really great modeling, and still you could be focused on the wrong problem. And so a good example of this would be, let's take COVID-19, right? So let's say that the company that's working with a pharmaceutical company, for example, someone wants them to develop a vaccine, and then another one wants them to develop a some kind of a pill that will help once someone gets COVID-19. If you pick the wrong one and you develop, let's say, the pill only, that, and you did all the research and you deployed a model that predicted how people would do after they got COVID-19 and help them. On one hand, it's great that you solved this one kind of a problem, but the people in your company might have wanted you to focus on the predictions about how to make the best vaccine. So you worked on the wrong problem. Again, it doesn't mean it's not potentially useful in some way, but you're focusing on the wrong thing. So that's really the idea, I think, with MLOps is get full automation plus the right business case. If you get all those together, then you're able to do production machine learning. So what are some other use cases for MLOps? I think autonomous vehicles in particular are an amazing use case for MLOps. Like, for example, are you able to go through and build out solutions that are able to take cars and make them safer, right? I think that's a great use case. And in fact, one of the things that I think is a little bit of a problem right now with autonomous vehicle research is it seems like people want the holy grail again versus only solving automation components of autonomous vehicles. Like, why don't we focus on both, right? We don't have to only do the holy grail of full self-driving car. Why don't we also work on making cars safer? Likewise, implementing machine learning in production from zero, I think, is another place that's a lot of traction. Hugging Face is a great example of this. People are using pre-trained models to solve problems. I think we're only going to see more and more of this. And then we have applied computer vision. So in terms of applied computer vision, this is where we are going to see that people are going to focus on more of the pre-trained models or high-level solutions or edge-based machine learning models and solving actual problems. And so this is where MLOps can really come into play, as if you focus less about how you did it and more about the problem that you're solving. Just again, like the construction worker may not necessarily care what model tractor they're using. They get paid whether they grade the lot next door or not. And that's really what I think should be done with machine learning as well, as it's more of a solutions-based approach. And then the real-world reliability versus potentially the research environment. I think this is a key problem that we'll see more and more of, is how do we make things more realistic? Okay, so let's get into some code. We did a lot of theory here, but I'm going to dive into a little bit of code here next. So what I'm going to do is I'm going to start off with GitHub. And in fact, you can do the same thing that I'm doing. Is I'm going to go to MLOps Cookbook here. There we go. This particular cookbook is from the book Practical MLOps. And the idea here is that what we're seeing as a trend with machine learning is that you can build once and deploy many. And so, in particular, you can see there's lots of different assets, and I'll talk about those in a second. But here's the idea: is that I can actually build GitHub Actions, I can build container registry, I can do these predictions, a Flask web app, a Click command line tool, a container. I can deploy to Fargate, I can deploy to Google Cloud, I can deploy to Azure, because a lot of it is container based, especially. And so these are, I think, probably not always necessary in a machine learning project, but these are just some ideas for people to focus on as, one, a makefile here, right? So, are you able to build out the steps involved in a makefile so that you have automation and really a repeatable way of doing things? I think this is not said enough, is that are you actually using makefiles to automate your code? Make has been around for quite some time. It's very bash centric as well. And so I would recommend that people use makefiles in their code. And again, I talk about this in Practical MLOps. Likewise, requirements file here for a Python project, it's a good idea to pin your version number. And so we see here, this is the particular version number. Here's the version number, right? These are all pinned inside of this particular environment. Now, if we go back here, we also see I have built a couple command line tools. And what's great about these command line tools is that, in particular, if we see this, that I like to actually build something that uses a library that does the prediction. And I think this is a good pattern to think about when you're building machine learning code, is why not build it into a library where you have, let's say, a predict function or whatever high level functions you need. And then look, when I want to make a command line tool, it's trivial. I just go through here and I say predict, right? And I make that prediction. And this can oftentimes be the straightest line, the quickest way to get to a solution, right? You have the straight line is the shortest path between two distances. Likewise, a command line tool is the straightest path to actually getting machine learning models that serve out in production. And then here is a very small microservice. And here's a good example. We have a Flask application, and we have a route that's basically hello world. And then we have a route here that's a predict and a post method. And in general, this post method will accept a payload. And this JSON payload will basically allow us to input into this microservice. So because I have the library that I wrote earlier, right, this import MLlib, inside here I say mllib.predict, and it's just a few lines of code to build a microservice. I think Flask is a good option for Python, but also Fast API is a great option as well. They both work, equally well for microservices. The other things to consider would be, for example, a model file, and you can see it's just a serialized model. In a cloud-based environment, more likely this would be stored inside of your data lake, like S3, and be versioned, and then Docker. At this point in time, I think especially with 2022, I don't think you're going to see anything in machine learning that doesn't use some kind of container technology. So I think we're now past that era of, you couldn't use containers. Everyone now knows it really does make things simpler because you have a standardized process to build your machine learning code and then put that into production. Okay, so the final thing that I'll maybe bring up here real quick is, notice this, we have the Python MLOps cookbook, is that if I go here and I open this up, what's nice about this is that we have a list of all of the different things that you would do in a machine learning project. I think this is a good idea when you're building out machine learning code, is to have an ingestion phase, exploratory data analysis phase, a modeling phase, right? Go through here and actually do the same thing when you put this into production. So here we go, import pandas as PD, data frame equals pd.read CSV. And then we also have the ability to kind of go through and do typical data science things. I think this is a very good idea to always have a notebook that's associated with your project kind of side by side, because this allows you to to really get a good understanding of what someone was thinking when they were building your project. So this is almost like a manual for someone that's working on your project. So in general, I think those are the core components that I would recommend in a project. Now, once you do that, one of the things that you can do is, again, you can deploy to all these different kinds of environments. So I think AWS is probably the cleanest one to play around with first. So let's go ahead and get into that. So I'm gonna go here and I'm going to go to code, and you're gonna see this is the code that I'm gonna copy. So let's go over to our AWS environment and let's launch one. Go ahead and do that. And here we go. And off. All right, 640. Oh, gonna do this again. All right, here we go. So what I would recommend on the AWS platform is there's really a couple flavors for doing MLOps. There's actually 3 flavors that we could look at. One is the Cloud Shell, right? If we go here, you can, if you want, just get everything running in the Cloud Shell environment. And there are some things that are pretty cool about the Cloud Shell environment. In particular, if you are familiar with the shell, it's actually a pretty clean way to start developing code and testing things out, and maybe like a quick and dirty way to just start building stuff out. I've actually really gravitated more and more towards on AWS, trying a lot of my ideas out inside of the AWS Cloud Shell environment. So in a nutshell, I think this is a really good way to get started. So let's just give this like probably take like 10, 20 seconds to spin this up. Now, I guess if I want to be efficient, what I could do is while this thing's spinning up, also open up a console here, and we'll go to Cloud9. And what I can do is also set up a Cloud9 environment, which is a more full-featured editor environment, so we can try out some richer things. So I'm going to do that as well, and so we'll have both, and we can toggle back and forth between them. So first up, we'll just call this MLOps demo December 21, and I'll go to next step. This is something that is worth talking about for a second. Is probably the defaults are okay for you. But what I would recommend more likely is that if you are doing something that's a little bit intensive, that you could use a larger instance. The difference here when you pick these instance types is that a lot of times this is probably good enough. Because I do a lot of demos and I want things to be very, very fast, I typically will pick the larger instance, and then I would again leave Amazon Linux because that's going to be your deploy target. And so this is the real thing about these cloud-based development environments, is that they're a target for you to build out your machine learning code to. And so you want to have the same development environment as you have production. That's really a DevOps best practice. We go next. Create environment. Now, this is what's cool about this is it'll also auto timeout. So I don't really have to worry as much as I typically do when I build out things in the AWS cloud. So we'll let this thing kind of cook there in the background, and I'm going to go back to the Cloud Shell. Okay, we're at the Cloud Shell, and I'm going to show you how easy it is to check out code. In fact, I've got some code inside of here. I'm going to go ahead and clone a different repo, which is the MLOps Cookbook repo. And a couple things I'll point out. One is every time I work on a project in Python, I like to create a Python virtual environment because of the fact that it allows me to simplify how I'm working on a project. So in particular, what I'll do here is I will say Python 3 -m venv, and then I like to put it inside of my home directory. So we'll just do this. We'll call this one MLOps. So it's kind of hidden. I don't accidentally check it back into the repo, which is annoying. You know, it's ready to go and it's baked. So now I can just say source.mlops and activate, just like this. Okay, now that I've got this thing cooking, here we go. I can actually go in and I can see Python MLOps Cookbook, and then we can do a make install, right? Or let's go to the make file. Let me see all the different things we can do. In fact, the laziest, and I like lazy, is you just say make all. Why do you do make all? Because it installs our software, it lints our software, and it tests our software. Okay, let's go ahead and do this. Let's do a make all, just like this. Here we go, pip install. We're installing the software. And what's nice is that because we pinned the version numbers of the software, we're reasonably sure that the things will actually be able to be installed. Now, if I didn't, who knows what could happen? I mean, the libraries are under active maintenance. So I think, well, here we go. We have one problem, which is fortunately a pretty simple one, no space left on device. Well, let's fix that. So what I can do is come back up here, and I can remove, let's say, cats and dogs. That looks like it's probably a lot of data. And let's see, maybe I'll remove this, some other code I was working on right here. So these cloud-based environments, always you get this problem, is that they run out of space, but it's pretty easy to fix, fortunately. There we go. And you can check it by doing df-h, and it should give us available. Here we go. We have 12 megabytes available. It's not nothing. we have a little bit more room here. Okay, so let's go ahead and I guess I could delete these core things as well, like this. Okay, and then if we double check, we have let's see, a little bit more room, I believe, available. Which, yeah, okay. So we're in good shape. I can go ahead and do the same command I did before, which is make all. But I need to cd into the Python MLOps cookbook, right? Make all. And again, because the make file has all my information, it's just, I can just restart again. And this is one of the core concepts of a make file is there isn't a lot of guessing, like, oh, what command do I need to run? And what do I have to cut and paste somewhere? I just say make all, right? And if I want to give this project to another person, same thing. I just say make all. And I think the make file concept is one of the most important concepts for all of software engineering because of this idea. You just say git clone, create an environment, make all. Here we go. We're testing our code here. Everything's perfect, right? Now I can prove to other people that this actually worked out well. Now the next thing that we can do is that I'm going to actually run something. And so how do I run something? Well, I can do this. I can run Python CLI. That's one way to run it. Or we can even do .cli, and I can do a help. Now let's see what we have here. It says, oh, predict the height of a MLB player based on the weight. So this is going to use the library that's included inside of my code here. So let's go ahead and do that. Let's go ahead and do weight. And let's say if I was a 220-pound baseball player, I would be what height? Probably 6'3", right? And if I was a 150-pound baseball player, a professional baseball player, well, what height would I be? I'd probably be 5'11". So you can see here that I'm able to get some good predictions. And because I have this really cool colored output, this is a useful tool. So for an organization, as I mentioned earlier, I think this is really important way to think about working. And in fact, the fact that I can use a Cloud Shell really quickly get it going is awesome. Now, let's shift gears here and talk briefly about a more full-featured environment and some of the things we can do. The first thing you need to do when you use a new environment that you created from scratch, you don't have to do it again afterwards, is you have to create an SSH key. Let's go ahead and do this. Here we go. Perfect. And if I go here and I print this out like this, at this, print it out, there we go. So if I go to this and I go to GitHub, I would need to go to my profile, go to settings, go to SSH and GPG keys, say new SSH GPG key, and we'll say MLOps. Let's go ahead and add this. Once I've done this, it'll ask me for a password, which I will do. And now I can go back to this environment and I can check out some code. So that's just kind of more of a a housekeeping type thing that we need to be able to do. Now I could go here and say get remote -v to just get the thing that I'm going to clone. And let's go back to this environment and just say get clone. There we go. Same thing. We're going to say yes. Now I'm going to CD into it. And because we know the story, create a virtual environment first, right? So do the same thing. Python 3-m -v tilde MLOps. There we go. Now, one little trick that I'm going to show you that I think is a really good idea is that I would recommend editing your bash RC file so that you don't have to sort your virtual environment all the time. So I do Shift G to get me to the bottom. And then what I do is I add a note here that says adding virtual env to my bash RC. Here we go. We just say source. We say MLOps bin activate. Like that. Perfect. And now if I save this, what I can do is I can say bash. All right. Now that I've got this thing sourced, anytime I open up a new shell, here we go, new terminal. Look, there we go. I can see that this thing is actually sitting there, right? Which, in my opinion, is a great way to work. And similarly, if I cd into this directory, all I have to do is say make all, right? And once I run make all, we're in great shape because this allows me to start building out a little bit more of a rich environment because I have a GUI. And in particular, this is the one I want to run next here. Once the installation is finished, is I want to run this microservice to just get a feel for how this thing works. Okay, let's just let this thing run. We're almost done. Okay, looks like code things pass. So again, I think is so critical, right? Is that I can actually install, lint test. I have pretty good feeling now that things are going to work. Let's run the microservice. Here we go. Now it's running in foreground mode. Awesome. And in fact, one of the cool things about using this environment, if I wanted to, is I could even open up a GUI and or a web browser and open up ports on here and do all kinds of development. But I'll just make it simple, which is I'll just run, I think I have a predict function here, right? There we go. We can see what the predict function does. In fact, if I look at it, all we need to do is go here and put this inside of, port 8080 and make a JSON-based prediction. So we've got a lot of good stuff working here. The final thing that I'll show you on the AWS environment that I would recommend playing around with is that if you go to AppRunner, this is a great place to deploy your code. I think one of the simplest platform as a service offerings that are available. In fact, we have a couple of different examples here of services I've got running, that do things. But in general, if we look at these services, it gives you an HTTPS endpoint, and it's very straightforward to get it running. Let me walk you through how that would work. First up, we go here. You can either give it a container registry. So again, this is why I think containers are such a critical component now to building out software, is that you can push a container somewhere and then it'll just deploy from the container. So every time you do an update to your machine learning product, it'll get deployed to production. A second way is a source code repository. I've tested both with the MLOps Cookbook code. They both work great. In this particular example, though, again, I could just go down here. I could find my repository. In fact, why don't we do that? Let's just go through here and find the MLOps Cookbook. And you could, again, follow along if you wanted to, and this should work exactly the same for you. Go down here. Python MLOps Cookbook, perfect. And probably manual is a good place to start with. You could do automatic, but it's, I think, a little easier to debug. Configure all your settings here. Choose an AppRunner runtime for your service. Here we go, Python 3. And then I say pip install -r requirements.txt, and then say Python app.py. Perfect, just like that. And then from here, I could go through and call it some kind of a service and say MLOps service, just like that. And then you can see here that I could also set up things like auto scaling or even have some kind of custom configuration. And then I could even develop my own health checks for the application as well, and tweak that a little bit, and even define instance roles as well. So if it needed to call out to other AWS services. So I think this is a great service to use. And basically, once you've got this thing set up here, we'll just say MLOps service. You just say next, and then we go through here and we do a deploy, and that's it. And then I can do the same kinds of things that I was doing earlier, except for in that case, I would do the prediction to this endpoint. So just to maybe wrap things up here, what I would recommend for people is that if you want to just really quickly get a feel for MLOps, I think the Python MLOps Cookbook is a great way to do it. And it's a very intentionally very simple application because it can work on pretty much any cloud platform. You can take this project and play around with it. It works very well with container-based systems. And yeah, go ahead and take a look, try Chameleon tools, try to do microservices, and just maybe kick the tires on this a little bit. And then once you've got that down, you can go on to more complex systems.